Good day, viewers. This is Ademola Johnson, your science tutor. In the series of electronic configuration in chemistry we have started, let's continue with atomic orbitals. Now, what is atomic orbital? Now, an atomic orbital is the region in space where the probability of finding an electron is high. When we say probability is the mathematics of chance, where the chance of finding electron is high. Don't forget, in the previous video where we started the electronic configuration, I told you that there are two parts of the atom where electrons are found. Number one, atomic shell that we did in the previous video. Then number two is orbital. Orbitals are like rooms inside the house. The entire house is the shell, while the individual rooms, they are the orbital. So you should know that the probability of finding human being in the room is higher than finding human being in any other part of the house. So that is it. So now, let's look at the types of orbitals. We have types of orbitals. There are four types. There are four types of orbitals. What are they? These are, number one, we have s orbital. Number two, we have p orbital. Number three, you have d orbital. Number four, we have f orbital. So let's begin to talk about them one by one. Let's talk about features of s orbitals. Now, number one, let's talk about the shape. It is spherical in shape. That's spherical shape. Number two, it has only one degenerate orbital. Then number three, it holds the maximum of 2 electrons. Carries maximum of 2 electrons. So if you want to draw, don't draw a Cartesian plane. This is your y-axis. This is your x-axis. Then this is your z-axis. Are you aware we still have z-axis? So just draw a spherical thing like this around this Cartesian plane. So what you have here is the diagram of s orbital. So that is that. Now let's look at features. Features of p orbitals. Now number one, the shape of s orbital is spherical, but p its shape is dumbbell. Bell that cannot talk, that cannot speak. Dumbbell. We cannot say figure 8. I will show you. Number two. Now, it has the following 3 degenerate orbitals. It has 3 degenerate orbitals. We have px orbital. We have py orbital. And we have pz orbital. Just like somebody that rents an apartment and he divides the room into 3 other spaces. So each of those 3 other spaces are called degenerate orbitals. Then number 3 feature is that each of its 3 degenerate orbitals can hold the maximum of 2 electrons. If each of them, Ps can carry maximum of 2, Py can carry maximum of 2, Pz can carry maximum of 2. So what is the total number of electrons that P can carry altogether? Can that is 6. 2 plus 2 plus 2. So P orbital can hold the maximum of 6 electrons. Let's make a sketch of each of these orbitals. Let's draw our Cartesian plane. This is y-axis, this is z-axis, and this is x-axis. So now, if look at my figure 8 is facing x. So this is the diagram of P what? Px orbital. Now, then if I draw something like this, this is y-axis, this is z-axis, and this is x-axis, and I direct my DC to the direction of y-axis. What I have here is the diagram of Py orbital. Now, yes, if I now have something like this, y-axis, x-axis, and I have z-axis, and I direct my shape like this to go in the direction of this. What I have here is the diagram of Pz orbital. So that is that. So let's look at the features of d orbitals. D orbitals. Let's talk about the shape. Its shape is double dumbbell. Double dumbbell. Number 2, it has, now this one has 3 degenerates. This one can carry maximum of 6, add 5, add 4 to 6, that's 10. So this one has 5 degenerate orbitals. Now, number 3, each of its 5 degenerate orbitals can hold the maximum of what? Maximum of 2 electrons. So if 5, each of them carry maximum of 2, then the total number will now be what? So d orbital can hold the maximum of 10 electrons. So add all the 2 times 5, that's 10 electrons. Then the next one is f orbital. Features of f orbital. Number 1, its shape is a complex shape. Complex shape. That's complex shape. Number 2, it has 7 degenerate orbitals. Now, number 3, each of its 7 degenerate orbitals can hold the maximum of 2 electrons. If there are 7 spaces and each of them can carry maximum of 2, then total number of electrons that the orbital will carry is what? 14. So d orbital can hold the maximum of 14 electrons. Take note of that. So the next thing we are looking at is the relationship between orbitals and atomic shell. Relationship between orbitals and atomic shell. Relationship between orbitals and atomic shells. Now, let's look at that. Now, I have told you, although, so electrons, the relationship between an orbital and atomic shell is similar with the relationship between a house and bedrooms. So the entire house is synonymous to the atomic shell, while the atomic orbital now looks like bedroom. So in a nutshell, summarily, orbitals are smaller spaces for electrons inside each atomic shell. Let's look at what we are saying, serial number. Let's start with atomic shell. Then let's talk about maximum number of electrons. 2n squared, that we did in the previous video. Then let's talk about containing orbital. Then maximum number of electrons. Again. So the first one is K shell. We have said that using this formula, when your n is 1, K shell can carry maximum of 2. We have discussed that in the previous video. You can watch it. Then what is the orbital it has? It contains 1s. Why is it containing 1s? The value of n. Don't forget, I will still tell you what n means later. It's 1 because it's number 1. So K shell is number 1, so its n is, so that's why the coefficient of this s orbital. And 1s orbital can carry maximum of what? Of 2 electrons. So take note of that. Then number 2 is L shell. L shell, the value of n is what? Is 2. Then the maximum number of electrons it can carry according to our formula. Put 2 here. 2 to the power 2. 2 to the power 2, that's 2 times 2, that's 4. That 4 times 2, that's 8. We have done in the previous video. Now, K shell contains s orbital and p orbital. But what is the coefficient? Whatever thing that is n, 2, 2. It contains 2s orbital, and anything s orbital, whether 2s or whether 3s or whether 1s, so they can carry maximum of 2 electrons. P orbital can carry maximum of 6 electrons, which we have done. Now, then in total, when you add them together, the maximum number of electrons that this L shell can carry, 2 plus 6 is what? Is 8. So that is, we can see that this 8 is equal to this number. Then number 3 is what? N shell. N shell, the principal quantum number is 3. So put 3 inside this N. 3 raised to power 2, that's 3 times 3 is 9. 9 times 2 is what? 9 times 2 is 18. Can carry maximum of 18 electrons. Then having done that, then let's confirm this. Now, this shell contains s orbital, which carry maximum of 2 electrons. It contains p orbital, which carries maximum of 6 electrons. It contains d orbital, which carries maximum of what? 10 electrons. But take note, what is going to be the coefficient here? What is this? That's 3. 3, 3, and 3. So now add the 3 to the whole thing together here. 10 plus 6 plus 3, that's 18 maximum number of electrons. So then lastly in this place, number 4 is N shell. N shell. N shell. Now, in the case of N shell, the principal quantum number is what? Is 4. So put 4 inside your formula here. Put 4 inside the formula here. You have what? 32. Then here, what do we have? This one carries, it contains what? 4s. Okay. Sorry. Now, 4s, which carries maximum of 2 electrons. 4p, which has 6 electrons. Then 4d, which has what? 10 electrons. And 4f, which has 14 electrons. Add them together. That is 32. So that is what we have there. So, okay, the maximum number of electrons they can carry. So I should add this in this column. I should add this in this column. Maximum number of electrons this N shell can carry is 32. 32. Then the orbitals it contains are what? Is 4s, 4p, 4d, and 4f. S will carry maximum of 2. This one will carry maximum of 6. This will carry maximum of 10. Maximum of 14. Add everything together is 32. Then why did I get this 444? Principal quantum number is what? Is 4. So you can see the relationship now between atomic shell and atomic orbital. It is inside shell, you have orbital. So now the idea is that K shell has only one orbital, which is 1s. L shell has only two orbitals, that's sp. M shell has spd, while N shell has spdf. First one is s, second one is sp, next one is spd, next one is spdf, and the coefficient changes due to the principal quantum numbers each of them has. So later we are still going to look at spdf electronic configuration. There you will know, you'll be able to arrange, you have 1s, 2s, 2p, 3s, 3p, 3d, 4s, and so for the first 30 elements we have it there. So we are going to the next one we are going to now is the laws governing electronic configuration. The laws and the principle that govern electronic configuration. Then we are going to state Hund's rule of maximum multiplicity, Haber-Bosch's principle, Pauli exclusions principle, Heisenberg or certainty. See you in the next video when we are going to do that. I remain my humble self, Afi Adebola Johnson. Share this video, like it, subscribe to my YouTube channel, Afi Adebola Johnson, and you'll be blessed. God bless you. Bye for now. Thank you.